So the very first thing that we're going to do is the Hindu-Arabic numeric system. So we've been doing numbers pretty much, all our lives, but there is a way as to why numbers are the way they are. Things have been going on for ages. So the Hindu-Arabic numeric system is the one that we use on a day-to-day basis. If you get technical, this is what we call the base 10 system, and I'll explain as to why that is in a bit. Where does the Arabic part come from? If you go back and look at history, the number 0 Arabic, if I recall correctly, I could be wrong, I'm not a historian, but I think somewhere in Persia, now Middle East, somewhere perhaps Iraq, is where it originated. So the 0 number is Arabic, but 1 through 9 all the way up to 9 are Hindu numerals, and they've been around for a long time in their scriptures and whatnot. So it goes way back. Now, I'm going to write all the numbers. So that seems very trivial, which in fact it is. 0 through 9. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 basic numbers. Easier way to remember is base 10. A fancier name for this would be the decimal base. Now, anytime we deal with numeric systems, we want to know what type of conversion to use or how to interpret the number. So in order to do that, we've got to know something called exponents, which are quite simple. I'm just going to use 10 because we're talking about base 10. 10 raised 0 is 1. 10 raised 1 is 10. 10 raised 2 is 10 times 10, which is 100. 10 raised 3 is 10 times 10 times 10, 1000. And it can keep on going. So this is what we call an exponential notation. And we will need this when we get into the numeric system in detail. Now, base 10, because we have 10 basic numbers, starts at 0 and it stops at 9. And that 9 is simply 10 minus 1. Now, one of the important things, of course, you could go back and say, well, we have more numbers, and how do we account for them? So it goes back to the same basic set of numbers that we have. I've written 0 through 9. So what should I do if I have to count beyond that part? So I'm going to take 0 through 9, but add 1 in front of it. If I did that, I'll get 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. That would be the next set of numbers. And if you want to keep on counting, well, I did the initial basic sequence, 10 basic numbers. I put 1 in the front. I proceeded the second set of numbers. The next step would be to put 2 in front of the basic numbers. So I have 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. The reason why I'm doing this with the Hindu-Arabic Numeric System is because this simple logic is applicable to pretty much any base. So if you can understand the process here, you can understand it for other bases. So we want to write the Hindu-Arabic numeral in expanded form. So of course, in practice, we don't want to write things in expanded form, but what we're trying to do is understand how things are counted. So the Hindu-Arabic numeral is based on powers of 10, so let's not forget that. And it starts at 0. So if I have 36, I can write it as follows. So 10 raised 0 multiplied by the number in the first position or the first place, which would be 6, times 10 raised 1 multiplied by the second digit or a number in the second position. So 10 raised 0 is 1. So I will have 6 times 1. 10 raised 1 is 10. So I'll end up getting 30 plus 6, which is 36. So the expanded version of 36 is simply whatever I have on the right. And you can see that I'm starting at 10 raised 0, then I move on to 1. And I can keep on going. If I had 300s, then I would go to 10 raised 2, 3000s, then 10 raised 3, and so forth. Since we have a position and a value corresponding to the position, so the Hindu-Arabic numeral system is what we call a position value or a place value system. So because we look at positions and assign values corresponding to those positions. So here we have the number 127. So 127 is bigger than 100, which would mean we need to have 10 squared in our expansion, because 10 raised 2 or 10 squared is 100. So there are 3 digits . start with 10 raised 0, 10 raised 1, 10 raised 2, and the corresponding positions have values 7, 2, and 1. So we have the position and we have the values. So position would be 10 raised 0, 10 raised 1, 10 raised 2. The values would be 7, 2, and 1 in each of those positions. I guess the arrows are in the wrong place. Let me just fix this. Could I have it backwards? So 10 raised 1 position, 10 raised 0 position, and those are the values. My bad. So the values in the 10 raised 0 position is 7. 10 raised 1 position is 2 and 1. This is what you might have learned as the 0th digit, or the first digit, the second, or 0th, 10th, 100th, 1,000, and so on. So 0, because it's 10 raised 0, 10th, or the first digit, 10 raised 1, 100th, second digit, because we have 2, and 10 raised 2 is 100. So all we have to do is recognize that there would be 3 terms. The first one would be 10 raised 0 position, 10 raised 1, 10 raised 2, and we can plug in the digits 6, 9, and 8. You can always verify the answer by putting it back in a calculator, and it should sum to 698. So key thing to note here is I have 4 digits, so I will have 4 terms in my expanded expression. So 10 raised 0, 10 raised 1, 10 raised 2, 10 raised 3. Then I'm going to put in the digits 7, 0, 7, 4. And most people would simply call that last term, or write that last term as 1. And the most people would also include me. But the reason why I like to write it the way I'm writing it is to demonstrate that we are going in powers of 10. So I have an expanded form, 7 times 10 raised 1 plus 4 times 10 raised 0. Of course, these days we can use a calculator, but we're just trying to make points in terms of number systems. So there are only 2 terms, so 2 digits, but you've got to be careful. When I say 2 digits, I'm looking at the power. So 0 and 1. So whatever answer that I would have would be in tens. So 7 times 10 raised 1 is 70. 4 times 10 raised 0 is 4. The answer is 74. The reason why I wanted you guys to be careful when it comes to looking at the number of terms in the expanded form is because of something like this. You would look at that and immediately say, oh, there are only 2 terms, so the answer must be in terms of tens. But we've got to be careful here because that's 0 and that's 2. So I have actually moved 3 digits, 0, 1, and 2. So the answer must be in terms of hundreds. So when we write this, this is actually equivalent to saying 8 times 10 raised 2 plus 0 times 10 raised 1 plus 4 times 10 raised 0, which would give us 804.